Before we learn this word concavity, let's just remember what you know about increasing and decreasing. You knew before you got to calculus that when a function goes uphill, it's increasing. And when a function comes downhill, that's where it's decreasing. So that's not a calculus topic. That's just a word we use to describe graphs. And then it turns out that in calculus, we have some math we can do to describe physically, using algebra, when a function is increasing or decreasing. And that's by checking the derivative to see if the derivative is positive or negative. Okay, so I have one more pair of words to tell you about. And these are not calculus words, but we're going to learn in a second some calculus we can do to understand them. Where is this? So come back up here. Nope, come to this PowerPoint file. And I want to tell you about the word concavity. Maybe you talked about convex and concave, maybe in your physics class, about lenses. Guessing. So just, this is not calculus, this is just, you need to know that this curve is concave up. If you're going to try to explain it to your little brother, or a class of AP calculus students, it looks like a bowl. Concave up looks like a bowl. It looks like it would catch rainwater if it rained. Concave down looks like an umbrella. Yeah, there you go. There are more formal definitions, but that's pretty much what you need to know. The thing is that a parabola is either all concave up, if it's an open up parabola, or all concave down. But most other functions have places where their concavity changes. So here's an example. I have this little picture drawn in. That black dot right there, that's a place where the concavity of this curve changes. So if this is the black dot, I'm going to try to match how the picture looks to you. This part was concave down. And then this part was concave up. And the point, the one place where the concavity changes, it kind of changes from an umbrella to a bowl, that's called a point of inflection, or sometimes we say inflection point. They're both correct. So somebody might have taught you those words already in pre-calculus. I don't know. We could put them in the pre-calculus curriculum, but they don't typically happen to show up. But that idea of a function being more like a umbrella in one place and a bowl in one place, you could teach that to an Algebra 1 student. It's not a calculus idea. But these are some new words that we need to know. Now, it turns out that we can use calculus to help us figure out where a function might be concave up or concave down. So this is where the calculus comes in. All right, I'm going to show you this slide, but this slide is a little bit defective because my little double prime markers on my f functions didn't really come in. So I've tried to write them in. I want you to see this picture, but then I'll go and I'll actually show you how to type this in. Well, I'll type in the answer to show you what it would look like on your notes paper. So a function f, assuming you could actually find its second derivative. That's what twice differentiable means. So if I'm looking at your notes, it says the graph of a twice differentiable function f of x is. That just means a function f that has a second derivative is concave up on any interval where the second derivative is positive. So if the second derivative is positive, f double prime of x is greater than 0, then your original function f was concave up. Any place where your second derivative is negative corresponds to places where your original function was concave down. Again, I'm going to show you how to write that because I recognize that this notation is difficult to read. All right, so a function f is concave up on any interval where f double prime of x is positive. A function f is concave down on any interval where f double prime of x is negative. A point of inflection, one of those places where we change from a bowl to an umbrella or an umbrella to a bowl, happens any place where your second derivative, so f double prime of x, changes sign. So you saw in the slide where it said f double prime of x equals 0 is a possible location for a point of inflection. Just the same way that a critical point, a place where f prime of x equals 0, is a possible location of a relative maximum, but you really have to double check that the sign changes In this case, we have to double check that f double prime of x actually changes sign from positive to negative or negative to positive for there to be a point of inflection. One of the most common errors on the AP test, and I promise they will check that you know this, is to report a point of inflection at a place where f double prime equals 0, when really, if you stopped and checked, you'll find that f double prime does not change sign there, so there's not a point of inflection. So there are at least two places on your 19 facts paper that are about concavity. One about where a function is concave up or concave down, and another about where a point of inflection occurs. Make 100% certain that you fill them in. We're going to do this example. So this example, page 208, example 3, find all points of inflection of the graph of y equals e to the negative x squared. Where does a point of inflection occur? It occurs where y double prime changes sign. So not just good enough to figure out where y double prime is 0. We're going to have to find where y double prime changes sign. We're going to do that by making another one of those sign charts, like a number line sign chart, for y double prime.